Now we will see node components in Kubernetes. I am host Trainer, and welcome to our second session of Kubernetes video, Node Components in Kubernetes. Kubernetes nodes are the worker machines in a cluster that run containerized applications. Each node contains essential components that ensure proper execution and management of workloads. The key node components are Kubelet Kube Proxy Container Runtime Engine. Let's see in details about Kubelet. A lightweight agent that runs on each node and communicates with the Kubernetes control plane. It ensures that the containers described in pod specs are running and healthy. Continuously monitors the node and reports the status to the Kubernetes API server. Acts as the node agent responsible for managing pod lifecycle on its host. Kubelet understands YAML container manifests that it can read from several sources. File path. HTTP endpoint. Watch acting on any changes. HTTP server mode accepting container manifests over a simple API. Let's see in details about Kube Proxy. 1. Manages network rules and enables communication between different pods across nodes. 2. Handles service discovery and load balancing for network traffic inside the cluster. 3. Ensures proper routing of requests from external sources to the correct pod. Manages the network rules on each node and performs connection forwarding or load balancing for Kubernetes cluster services. Available proxy modes. User space iptables IPs, alpha in 1.8. Let's see in details about container runtime. Hope you are getting the points. 1. The underlying software responsible for running containers on a node. 2. Common runtime options include 2.1 Docker, 2.2 Containered, 2.3 CRIO. 3. Works with Kubelet to pull container images, start and stop containers, and manage container execution. With respect to Kubernetes, a container runtime is a CRI, Container Runtime Interface, compatible application that executes and manages containers. Here are a list of additional services, which you can have a look. kubedns provides cluster-wide DNS services. Services are resolvable to service namespace svc.cluster.local. Heapster, metrics collector for Kubernetes cluster, used by some resources such as the horizontal pod autoscaler. Required for Kube dashboard metrics. Kube Dashboard, a general-purpose web-based UI for Kubernetes. Let's talk about the networking in Kubernetes. Kubernetes networking is designed to be scalable, flexible, and secure, allowing smooth communication between applications. Kubernetes networking allows communication between different components inside and outside the cluster. Here's how it works. 1. Pod-to-pod communication. 2. Pod-to-service communication. 3. External communication, ingress and egress. 4. Network policies, security rules. Kubernetes networking, fundamental rules. Kubernetes networking is designed to be simple, scalable, and efficient. Here are its core principles. 1. All pods can communicate without NAT. Every pod in the cluster can directly talk to any other pod. No network address translation, NAT, is required. This allows seamless service discovery and interpod communication. 2. All nodes can communicate with all pods, and vice versa, without NAT. Any node in the cluster can reach any pod, even if the pod is running on a different node. This ensures smooth communication across the entire cluster. 3. Pods have the same IP internally and externally. The IP address a pod uses to identify itself is the same IP seen by other pods and nodes. This ensures consistency and simplifies networking for applications. These rules provide a flat, connected network that enables easy scaling, security enforcement, and load balancing within Kubernetes. Let's see the Kubernetes networking fundamentals applied in detail. Kubernetes networking is structured to ensure efficient communication between containers, pods, and services while handling external traffic seamlessly. Here's how these principles are applied. 1. Interpod communication. Containers within the same pod share the same network namespace and IP address. They communicate internally using localhost, just like processes on a single machine. 2. Pod IPs are unique but ephemeral. Each pod gets a unique IP within the cluster, valid for its life cycle. However, pods are temporary and can be replaced, so their IPs should not be relied on for long-term communication. 3. Services provide stable connectivity. Kubernetes services act as persistent, cluster-wide endpoints, ensuring communication remains stable even as pods come and go. Services have a static cluster IP that abstracts pod changes. 4. External connectivity via load balancers. External traffic to the cluster is usually managed by a cloud provider's load balancer or an ingress controller. This ensures seamless external access while maintaining security and scalability. With these fundamentals applied, Kubernetes enables scalable, flexible, and reliable networking for cloud-native applications. Let's see the Kubernetes Networking, CNI, Container Network Interface, in detail. Kubernetes networking is managed through CNI, Container Network Interface, which acts as a bridge between the container runtime and networking plugins. CNI ensures that each pod gets an IP and can communicate within the cluster efficiently. How CNI works. 1. It defines a standard interface for Kubernetes to attach networking to pods. 2. When a pod is created, the CNI plugin assigns it an IP, ensuring it follows Kubernetes networking rules, for example, no NAT, full pod-to-pod communication. 3. Different CNI plugins provide unique networking capabilities such as network policies, overlay networks, and enhanced security. Popular CNI network plugins in Kubernetes are listed here, few of them are described here. 1. Calico, responsible for network policies, BGP routing, security focused. 2. Cilium, responsible for EPF-based, advanced security, observability. 3. Contiv, responsible for multi-tenant, policy-driven networking. 4. Contrail, responsible for SDN-based enterprise networking. 5. Flannel, responsible for simple overlay network, XLAN support. Each plugin offers different networking strategies depending on your cluster's security, scalability, and performance requirements. Hope you enjoyed this video session. Let's meet in next video of Kubernetes concepts. Thanks for watching. I am Z host trainer. Will see you in next video.